All right, so I wasn't originally going to do a video for this, but I thought that there's enough detail in here that I should probably go through and describe what's going on. So the purpose of this little demo is to show multiple player states within your game states and how to switch between them effectively using an array of sprite sheets as opposed to separate sprite sheets altogether, and how it can kind of reduce our work. So first up, this is just a regular demo that's similar to our gravity jumping demo. I've removed all horizontal movement, so the player can only jump up and down. So what happens here is, let me demonstrate it first of all so you can see exactly what it looks like. So we have Mario here who just kind of runs in the spot. This would be great for an endless runner and just continually your animation. Mario can jump by holding down the key, and as soon as I let go, he immediately starts running again. I don't have to do anything special here. He can jump if I hit the up key. Oh, sorry, space key. There we go. As many times as you'd like. Or I can be even holding down and then jump from the down position. I cannot, say for example, jump while he's jumping. I've taken that ability away. And I can't duck while he's jumping. So that's how that works. So now you can see how what the demo's doing. Let's see how we actually did it. First up, I have 3 player states. I have walk, I have jump, and I have duck. And I've given them numbers 0, 1, and 2. And I did this because these values are going to represent index values in our array. So our arrays are numbered from 0 up to length minus 1, if you recall. So down here, I have my sprite sheet array of 3 elements because there's 3 states. Now, I only have one vector2f player position. I only have one true position. And the reason why I do this, this is a conscious decision. The reason why I'm doing this is because I always want all of my player images to be in the same position. It's just going to make my life a lot easier if they share a true position. And then I can update their drawn positions according to that one true position. Otherwise, I'm trying to manage all 3 separately, and it can get very complicated. Now, that being said, if you have sprite sheets for your different actions, so your different player states that are different sizes, that may be an issue. So you may have to actually have different true positions if that's the case. Now for my images, I've kept it as simple as possible. So this is my walking image. You can see that they're all the same size. My jumping image is the same size as those. My Mario duck image, though, is low. It looks like it's low, but it's actually not. It actually has the same height as the other ones. So I am actually using, it actually has a whole bunch of dead space above it that is part of the image. So if I were doing collision detection with this picture, I would actually get true collisions for above this character's head. So if that's the case, what I would want to do is I would actually want to incorporate 2-stage collision detection like we talked about in the platform collision demo, where you detect collision with the bounding box, and then you have a separate rectangle that you check inside if it hits the big bounding box. But we're not going to worry about that right now, because all we're doing right now is demonstrating the different player states and moving between them. So that's why I'm sharing one player position, so it's much easier to update everything altogether. I still have my vector2f player speed, so the player can technically move in both directions. I still have my forces so that I can act on the player's speeds in both directions as well. So gravity is always pulling the player down. I'm never, in this demo, I've taken away horizontal movement, so I have my forces for my X component at 0. So I'm never going to be acting against the player in this game. I set my jump speed at negative 5.5 pixels per second. Pixels per update, I should say. Pixels per update when he's jumping, so that's his launch speed, basically. We have this variable called grounded, which tells us whether they're currently standing on the ground or not. And here is the variable that indicates what state my player is in. So I'm starting my player in the walk state. Now that's interesting, though, because when I first start my program, you'll see the player starts falling. So what happens is I started the player in walking, but the game detected that I'm falling, so it immediately switches states automatically to the jump state, because jump means that they're in the air. So I'll get into how that happens in a moment. So in terms of setup, there is a little bit more setup than before. I guess I don't need this line anymore. But you have to load in each image and each destination rectangle. So this is my array. I can't loop through because they all have different file names and things like that, so that doesn't really work. So I have to manually do it, unfortunately. So I have my player image at the walk index. Remember, I numbered those constants so they'd be the proper index values for my array. So this is really a 0, this is really a 1, and this is really a 2. So I'm loading the image for my walk. I'm loading my destination rectangle for my walk as well. I've actually put them all at the exact same location, so it's makes my life real easy. The one animation I have, which is him walking, is a very small animation of only 3 frames. So I'm actually duplicating it 5 times, so it really slows down the animation. Otherwise, it's too fast. Now, down to the player position, like I said, it's going to be a shared position. So I'm setting them all to be that walk animation's location first. So they're all going to start there, and I'm starting the animation for the walk immediately. The reason why I'm doing that is because I started the player state in walk, so it would make sense to start the animation. All right, so in update, let's look at how update happens. The update is not very big because I'm not doing much. All I'm doing is letting the player hit the space key to jump and the down key to duck. So in terms of the space key, as long as they're on the ground and we get the space key, we're immediately going to launch the player by giving them the jump speed, and we're going to set their player state to jump because they're jumping now. Now, just in case they were walking, I'm turning off the animation for the walk. Now, do I have to do this? Not necessarily. It just means that it'll keep animating while we're not drawing it anymore. So it's just a waste of resources. So I'm stopping the animation here. Although, like, you wouldn't notice much of a difference because the animation itself is only 3 frames. But if you have a much larger animation, that may come into being a problem. So anyways, so we've set our player state to jump, and we've given ourselves a jump velocity when we hit the space key. Now I'm going to skip over the down stuff for a section. We'll come back to that. And now here we are adding gravity to our speed. So our speed was set at negative, what did I say, 4.5 or 5.5 or something like that. And then we're adding gravity to this. So it's getting shrunk down a little bit. And now, if you guys recall this method that I created before, move game objects, it does that final step of moving our sprite sheets. It adds the speed to the player's position, so it adds the speed to the true position, and then it adds the true position to the sprite sheet's destination rectangle. All right, so speed to the true position to the draw rectangle. But the thing is, we don't have one draw rectangle. Now we have a collection of them. So I've updated this method a little bit to actually take in an array of sprite sheets. So the array of sprite sheets will actually update the true position and then apply that true position to all of the images. Let me just scroll down so you can see that. Right here, move game objects. So I update the one true position here, and then I loop through and I update all of the objects and set their destination rectangles to the true position location. So it's the same idea. I still kept the original one in here just so you guys had it as a frame of reference. I also, this is the original one right here. I also added another one which, instead of moving by a speed, moves the player or moves the game object to a specific position. So in this case, we're not moving by a speed, we're moving to a location. So this one says move game object to this X and Y. So it automatically sets the true position to that, and then it sets the destination the draw rectangles to that true position. It works exactly the same as the other one. It's just instead of adding speed to the true position, we're just setting the true position to a specific value. That's it. And I did the same thing for the arrays as well. So we have both. You have all 4 functions in there. And again, everybody, you're allowed to take any code that I have in my demos and use in your program or modify it however you need to for your game. So I've moved my game objects. Yay, now what? Well, now I got to make sure that the player doesn't collide with stuff in terms of like the walls. So our left and right walls, our top wall, and our ground. Now the left and right wall, we're not moving horizontally, so it's not going to be a big deal. I left the code in there just so you had it, but it is there. We're not actually going to be needing it right now. The top and the bottom wall, if I jump too high, I want to make sure the top of the screen stops me from going out of the screen. And then the bottom, well, that makes sure we know when we land on the ground. So that all happens in player wall collision. And that's one of the most important methods of this entire demo. So let's go down to player wall collision. So right here is where we do all the hard work. So this first piece right here is checking the left and right wall. So if we hit the left wall, I'm going to move all of my game objects to a specific position. That's why we have this move game objects to. And what position am I going to move them to? I'm going to move them to the same Y position. I'm not going to change that. The Y position is going to stay constant. So we're just going to leave that the way it is, still using the same true position. But the X position, I'm forcing to a value of 0. Why? Because I just hit the left wall. So I want to make sure that I'm not past the left wall. So I'm just forcing it inside the boundaries. The same thing for the right wall. I'm just forcing it inside the right wall. So the X value is set to the window width minus the player's width. And that's it. And the Y value doesn't change there. The speed, I want to stop them from moving horizontally, so I also set the speed to 0. So this hasn't changed. All I did was I just started using this method here from the previous examples instead of manually doing the multiple lines of code, because now we have a collection of images to move as opposed to a single image. So the code would start to get big and ugly. So this is why we use methods as well. So now let's look at the vertical. So this is when we hit our head, so when we go above the screen. So if our Y value is above the screen, again, we're going to move the game objects to the same X position. We're going to leave it as it is, but the Y value we're going to force to be a value of 0. So he's just inside the boundaries of the screen. And now the important one, which is the ground. So when the bottom of the player, so their Y position plus their height, so that's the bottom of the player, goes past the bottom of the screen, window height. That means we hit the ground. So this is what's going to happen here. This is where things get a little bit more interesting. First thing, we're going to shift just like before. We're going to shift the player so they're standing on top of the ground. We're also going to stop falling. So the Y speed is going to be set to 0. But we have to do an extra little thing here. So we are going to switch the player state back to walk because we just landed. We just landed from falling. Okay? But the thing is this, remember, gravity happens, pardon me, I'm about to sneeze. Sorry about that. Gravity happens every single update, whether we're jumping or not. So even if we're standing still, gravity is pulling us through the floor. So I don't want to set the player to the walk state if they're already in the walk state. That would be a waste. I also don't want to set the player to the walk state if I'm currently holding the duck button, because that would stop me from ducking. So I only want to set it to the walk state from falling when I'm currently in the jump state. So if I'm falling through the air, I'm not standing on the ground right now, then set it back to walk, basically resetting their position. And since we're going back to walk, we got to start the animation again. Great. Now what about the else case? So this is the grounded is just the variable saying that we're standing on the ground. The else case is this. Now look, this is, did I hit my head on the ceiling? Did I hit my feet on the ground? Everything else means I'm somewhere in between, which means we probably just walked off a ledge, right? So once we get into the platform collision demos, you probably walked off a ledge, which means we want to set the player state to jump. We want to stop animating the walk, just in case it is animating, and set the ground back to false. Okay? So that's the jumping, and probably the more challenging one of all the pieces. Let's go to the duck. The duck is a little bit interesting. I like this one. So the way we handle duck, if I can find it, here it is. If we get the down key and we're currently standing on the ground, we're just going to set the player state to duck and stop animating. But how do we know when to stop ducking? Well, when I get the key released. So this is when I'm holding it down, and this is when I let it go. So if I let go of the down key and I'm on the ground, then set me back to walk. Now what's interesting is if I'm currently holding the down key and I jump, well, if I'm currently holding the down key and I jump, that means that I've immediately done this work, because this happens before this. So I'm holding the down key from the previous update. We come in here and we say, oh, we just got the space key. Set the player state to the jump state. So they're no longer in the down state. They're no longer in any of these, where were they? We're no longer in the duck state anymore. So now it's actually taking over from the duck and we've moved into jumping. And then the Y speeds are going to take place, our velocities are all going to take place, and everything is going to happen automatically for us. We don't have to do any work. So the whole reason why we do this array of images instead of separate images is that we'd actually have to monitor and track each individual one. Here, we're just tracking a single collection, and it makes life a lot easier if we do that. So just again to show you that duck, I hold, and I release, I hold, and I jump. Now, if I'm still holding when I land, it immediately goes back down to the duck state. It actually goes into the walk state and then the duck state, because it lands first, and then it comes back up to the top of update. Hey, I'm walking. Oh, you have the down key pressed. I'm going to go to duck. Okay, so that's everything in terms of player states and going between the different states. Remember, the main thing here is that you have a collection of sprite sheets, but you only have one true position, and everything works back on that true position. So when you move the true position, you got to apply the true position to all of your sprite sheets, so they all move together. Okay, that's it for now. Good luck and have fun.